Good morning, everyone. Welcome back, and thank you for joining us. We're glad that you're here. I'm Steve,
And I'm Scott.
and together we are Backyard Musings, the Science and Technology channel.
Yeah, and once again, we are talking about a story that I have no idea about. I mean, if somebody had come up to me and started talking to me about this, I would have told them, hey, I need the Dr. Seuss version because I have no idea what this is. But it sounds cool. It's called the Predator Cloak. So that's all I can tell you at this point.
That's what we call it. A new 3D material can guide heat around complex objects while shielding them from extreme temperatures and infrared detection. Backyard Musings calls this the Predator Cloak. On an infrared camera, a warm object normally stands out clearly against cooler surroundings. Case in point, Bigfoot. If you're out there with an infrared sensor, you'll see Bigfoot, right? Researchers have now built a three-dimensional cloak for Bigfoot that bends heat around an object, erasing its thermal outline while protecting the space inside from temperature extremes. Would you like to know more?
Okay, the device is the first physical 3D thermal cloak designed to conceal complex objects from nearly every direction. Instead of stopping heat at a barrier, it redirects the flow around the hidden region and then allows it to continue along its original path. To an infrared camera watching from outside, the temperature patterns appears largely undisturbed, as though no object were present. So yeah, that's weird because I've seen infrared like night vision type stuff, right? That we're kind of what we're talking about here.
When you were Squatch watching, right?
Well, okay. Or if I saw it on a movie or I saw it on the news. You can see the figures. They're kind of distorted. And obviously you can tell because light is dark and dark is light usually, right? Isn't that works? But I don't understand a lot of what I just read there. So
it's taking, so it takes heat, a heat signature, and bends around it so that you can't pick it up on infrared. And it's saying that it protects you from extreme heat too. I'm thinking the next iteration is somebody's going to come up with something that completely cloaks you to the naked eye. Like it reflects back what's behind you or something like that. That's what I'm thinking is the next iteration.
Okay.
All right, this approach could eventually improve heat control around microchips and sensitive electronic components, and may also help protect equipment in severe environments and reduce the thermal signatures used to locate people and machinery. Space travel. Totally.
The research was carried out by the University of Illinois Urbana-Champaign civil and environmental engineering professor Shelley Zhang, postdoctoral researcher Weichen Li, and graduate student Weibo Wang. I did not make that up, nor did Steve. Working with Professor Ole Sigmund at the Technical University of Denmark. Their findings were published in Nature Communications.
Previous experimental cloaks controlled heat only across flat surfaces or along one predetermined route. If heat approached from another direction, the temperature disturbance created by the hidden object could become visible.
To move beyond that limitation, the researchers returned to the transformation thermotics, a theory that calculates how heat must travel around a protected region to make the surrounding temperature field look unchanged. The idea is similar to rerouting a current around an obstacle, reconnecting it on the other side without leaving an obvious disruption.
The challenge was turning that mathematical prescription into a structure that could be manufactured. Different regions of the cloak needed carefully selected thermal conductivities, meaning they had to move heat at different rates and along different directions.
Was that an obvious disruption that I just heard before you started reading?
A what?
Was it?
That was Cameron.
It was Cameron, yeah. Okay. The researchers, right? That's where I'm at?
Yep.
The researchers answered that problem with a lattice material whose geometry can be adjusted independently in 3 dimensions. Changing the shape and arrangements of the lattice allows each section to conduct heat differently. This broader range of thermal behavior brought the physical device close to the conditions predicted for an ideal cloak.
The next step was proving that the design could function as a real object rather than only as a computer simulation. Yeah, that's a big step there. The researchers combined two materials with sharply contrasting abilities to carry heat. They printed a precise aluminum lattice in 3D to create highly conductive pathways through the cloak. Aluminum moves heat readily, allowing energy to travel quickly through selected regions. The remaining spaces were filled through mold casting with a rubbery material that transfers heat much more slowly.
Together, the materials created a controlled thermal route. Some sections accelerated heat flow while others restricted it, steering energy around the space occupied by the concealed object. For the laboratory test, the researchers placed the cloak between hot and cold regions, producing a temperature gradient across the device. An infrared camera then recorded how heat moved through and around the structure.
From outside, the thermal pattern looked almost as though the concealed object did not exist. Heat passed around the protected region and rejoined beyond it without producing the strong distortion that would normally reveal an obstruction. Inside the cloak, the temperature stayed uniform and remained insulated from the surrounding hot and cold conditions. That's pretty cool.
The researchers then increased the difficulty by hiding intricate three-dimensional forms, including detailed shapes resembling human heads. These tests showed that the method could accommodate irregular geometries rather than only simple objects designed for controlled experiments.
My question is how it it blocks the heat, right? What if you're in the cold? Does it keep your body warmth inside the cloak? That's what I'd like to know. That'd be pretty cool. All right, the ability to guide heat around complicated forms could be useful wherever temperature must be managed with precision. In electronic systems, the cloak might redirect heat away from vulnerable components and prevent nearby heat sources from interfering with delicate devices.
It could also help protect equipment exposed to extreme temperatures. Security and defense applications are another possibility, including reducing the infrared signatures that allow thermal cameras to distinguish people or machinery from their surroundings.
The current device is designed mainly to redirect heat arriving from outside. Concealing an object that produces its own heat presents a more difficult problem because that energy would continue building inside the protected region and could eventually reveal its location.
Okay, Steve's got this figured out. Solving this challenge would require a cloak that responds dynamically. Rather than following one fixed thermal pathway, it would need to concentrate, distribute, or redirect heat according to changing conditions inside and outside the device.
The researchers now plan to investigate smart, multifunctional cloaks capable of performing those active tasks. Such devices could eventually do more than hide its thermal signature by deliberately controlling where heat gathers, how it spreads, and where it leaves the protected region. Just fascinating. Completely fascinating.
Absolutely.
Another way for Sasquatch to hide.
Right. Because, I mean, we don't know. Maybe Sasquatch is what would it be? If he's warm-blooded, then he's cold, right?
What if Sasquatch already has this? And that's why we can't see him.
But we have been able to see him.
I see what you're saying. Maybe when he wasn't wearing the suit. Maybe.
You think he can take his suit on and off, you think? Only during hunting season. Okay.
All right, folks. Thanks for joining us.
See you this afternoon. Thanks.